So we just got done building this chip in Onshape, and our desire is to have a 3D print of the part. So what we're going to have to do is we're going to have to export this file into an STL, which we can then import into a program that is called a slicer. We're going to use Cura today, and it will develop a machine code that we can send to a 3D printer for us. So our first step is we're going to go down here and export our file. You have your file name, you have your format, it needs to be an STL, and it's best if the units are millimeters for this situation. I've already done this, and so I can move quickly into Cura. I'm going to open up the file here. It'll generate in for me. And I've got it already in layers mode. And what that means is it will show all the different layers of that print for me right off the bat, which is, in my perspective, the best way to review the file. There is also, you can look at it as a solid, you can look at it as an X-ray, but really layers is what I think conveys the most information. Other things that we can do is if we have multiple prints, we can orient where it is on the part, and so we can shift those around. I can also do the same thing just by dragging and dropping. A benefit of working outside of layers is that it will allow you to do some of these things a little bit faster, but that's okay. We can scale it. So since we were exporting in millimeters, it came in the right scale that we desire it to be, but there's a lot of times I've had to take apart and then use a unit of conversion with this percentage to get it to be the right size. We have the ability to rotate it, and I want to make a point. There's not much difference if we rotate it along the base here, but we did position it flat on that plane just so that it would print and we wouldn't have to use support material. Because if I rotate this now, we'll rotate up 90 degrees. When it generates, we actually lose material right here, which is going to be for supports, just so it supports this edge as it's going up. It's really not neat if we can set it flat. It also allows there to be a grain right through the middle of it, which is going to be the weakest part of the chip. Whereas if we set it flat, the grain is going to be through the side, and it'll be a little easier to work with. You also have the ability to mirror parts and do other things, but at this point, let's get into our printers. I'm going to start by adding a printer. We're going to use the Makerselect Plus, which looks like this, and the big things we worry about are the size of the platform, because that's going to be what relates most here. So I'm going to go in, I'm going to add a printer, I'm going to go to Other. The Makerselect is actually a clone of the Prusa i3, so I'm going to type in clone, select Add a Printer. And that's not done yet, so I still have to go in and manage it. And in the clone, in the machine settings, we see that the sizes are not appropriate and the material diameter is the wrong size. And so I've got to change those two. Instead of doing that, I'm just going to show you the Makerselect profile I use. So here's my machine settings. So we have the correct size, we have the correct material diameter, and I also have the G-code that I'm currently using on my prints. And so what has to happen is when this program develops the file, it's going to have a startup process for the printer, which is turning everything on, moving things, homing it, checking to make sure it can extrude a little bit of material first. And then there's also a code for ending it. So that's turning everything off, again, homing some stuff, and like positioning the parts so it's easiest to pull out. Once we're good there, we are set. The close, we've got that in there. We are going to use PLA, and my recommendation really is to use PLA until you're efficiently bored of using PLA, because there's so many other different types of materials, which is great, but there's a lot to learn without shifting around, and the change of temperature and the difference in like sending a piece of material through that melts at 110 and then sending another one through that's 140 and then sending another one that's at 210, it causes some issues with the heads. And so I would recommend just sticking with PLA until we have a genuine reason to move away, and it just works better in my mind. As far as our draft quality, so they have different ones that we can sort of work with. I kind of feel that extra coarse quality is almost useless, whereas fine and extra fine are also kind of useless. And the reason is that they're just there's just so much information with that, and it's going to take the part so long. So if we see down here 20 minutes, if I shift it over to extra fine, I get an hour and 41 minutes, and so it's taking a significantly longer time, whereas this 0.2 millimeter is going to work just fine for us. I'm going to go into the custom settings here and just sort of walk you through some stuff. So our layer height, as I said, is draft quality, which is 0.2. And so it will allow us to have all those layers set up, each of them at 0.2 millimeters at a piece. Our wall thickness is at 8, and what that does is they're talking about how many of these walls go together to make that up. If I go down, so the thing I'll sometimes check, because I like having 2 or 3 layers there. If I change this to 6, it's going to take it down to just the outer wall and no interior wall, which is not desired of mine. And so I'm going to bring that back up to 0.8 to get those 2 walls, both the outer wall and the inner wall, back. I will say that with the infill density, this is probably the largest decision that most people make with 3D printers. And so if we have this, it's going to affect the part right here where this next thing comes in. And so what I'll look sometimes as far as infill is, like, see this T, how we have this edge where it's just sort of hanging off, right? If that's suspended over there and it's cantilevered off, sometimes you'll have issues with that. This is 1.5 inches in diameter, so it's really not that far off, so I don't think we're going to have any problems with it. But again, we're going to look at the 20 minutes time. If I change this up to 80%, we just added 7 minutes to our print, which is kind of significant. That's just under 40% additional time that's going to take for me to print. And it's just not needed for this part. And so we'll bring it down to 20. Our print temperature we shouldn't have to change. Our build plate temperature we don't have to change. Our diameter we shouldn't have to do anything with. I would not recommend messing with print speeds and travels when you're just getting started. I would enable cooling, and I would definitely have generate support already selected, because if you forget that at some point, it's going to cause you significant problems later on. The build plate adhesion is also another big decision, and so there are 3 different types. So there is none, of course, which is of course nothing. So it's just going to look like the part right there. The issue is that sometimes the head that's injecting has a little slag on it, and so not having something going in that's not your part first is sometimes a mistake. So I tend to choose a skirt, which just allows you to have this outside line right there for you to sort of empty the extruder. There is a brim where this is pretty much going to be utilized. Is, let's say this is a part that's really delicate and there's not a lot of surface area that's going to be between the base plate and the part, and so adding this brim here is going to make it to where it just adheres to the plate. It increases the surface area drastically. The bummer on this is that you will have to almost cut this off once you're done printing. The last option here is our raft. I kind of rarely use a raft. Now, a case I would probably want to do that is that if I printed this upside down, so there's a lot of detail on this, that raft would allow me to sort of protect the part from the peeling off process, but it is a significant amount of additional material. So we've got 6 layers there that are all just larger and they're just to support it, but we will get a clean surface right here. You can also see that it's not a untimely process. This adds 14 minutes to our part, and so that's, you know, it's 70% more time. That's considerable. There you go. Those are my settings. My next thing that I have to do to actually get this to print off is I'm just going to save this file as mstudent chip, and I'm going to call it 2, and I'm going to save that onto an SD card so that I can take it over to the 3D printer and print it out. I hope that works for you, and if you have any questions, feel free to reach out or comment below. Good luck.